Today we have an interesting question involving the composition of the divisor function with itself. And let's just talk about one of the properties of the divisor function. And I'll just use an example to illustrate. Now what this means is how many divisors does 20 have, and that would include 1 and 20 itself. Okay. Now this is a small enough number to where we can just enumerate. So 1 is a divisor of 20, 2 is a divisor of 20, 4 is a divisor of 20, 5 is a factor or a divisor of 20, 5, 10, and 20. So again, this function doesn't tell you what they are, it counts how many of them, and there are manifestly 6 here. But notice we can rewrite this as d of 2 squared times 5. Okay. And there's a convenient property here, and it's basically you have to allow for exponents of 0. But notice that this is equal to increment 2, and you get 3. Increment 1, and you get 2. And the reason why it's 1 more is, again, you have to allow for 0 to be an exponent to allow for 1 as a factor. And it's a little bit more than that. But anyway, you can see there's 6 here, and then this comes out to be 6 also. So this is a nice property of the divisor function that turns it into an incrementing of the exponents and then taking the product. Now what we're looking for is the smallest such natural number n, and n is a natural number meaning a positive integer, such that d of n is equal to 7. Now this result right here is pretty clear. Just if you take, you can write d at 2 to the 6th. 2 is a prime. And I won't write them down, but the divisors of 2 to the 6th are 1, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, and 2 to the 6th. That's 7. Okay, so this is equal to 6 plus 1. Okay, which of course is the 7 that you see right here. All right, so carrying on, it's a matter of rewriting 64 in a way where you optimize these exponents in a not optimize, but you want to minimize. Okay. Now, very important, we want the base of 2 raised to the highest exponent as possible. And that's also balanced by how many prime factors you're using also. Okay, but just in a general rule of thumb, you want to waste the base of 2 on the highest possible exponent, right? Because 2 is the smallest base. And 2 raised to a higher exponent is smaller than all the other primes raised to that same exponent. Okay, so the possibilities that I came up with, and I'm not convinced that this is exhaustive. I only came up with 5. This one here is because you have understood exponents of 1 here, 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 and here, right? And remember, you increment the exponents, and that's where this 2, 2, 2, 2, 2. So this is the candidate n for this particular factorization of 64, and so on. This would be your candidate n for this factorization of 64. And you can just see carrying on, it's the same all the way through. Right here we get to 15. That would be this guy right here, right? Or let's see, 15 and 3 would correspond to 4 times 16. 8 times 8 would correspond to the 7 and 7 you see right here. And finally, this one, which I missed. I did a video on this earlier, and I missed this one and a few others, actually. But this particular one would correspond to this factorization of n right here. Okay? Now, not of n, but of 64, excuse me. Okay? Now, so I won't go through all the comparison, but it came down to this one and this one right here. Okay, and you can see right here you have 3, 3, 3 all the way across, but here you've hooked up a 7 with the 2, right? And so it's about comparing which one is smaller. And so what we can do, you can do it any of 2 ways. I'm going to go ahead and write it as 2 to the 7th I'm going to do what they call a ratio test without having to use a calculator. This is calculator avoidance 101, folks. So we have times 5. So these are the two candidates. And again, there's some comparisons I didn't show you, but some of them are very, very obvious. And by the way, I did leave out 2 to the 63rd is a possibility, but that's obviously too large. Okay, so what we have right here is this 2 to the 7th, and I'm going to place it over our other candidate, 2 cubed. And you can see where I'm going with this. I mean, you can probably just see this right off, but it's just to be slightly rigorous here. Okay, now, so if this turns out to be less than 1, then this is definitely going to be the smallest one. If it turns out to be greater than 1, this one would be the smallest one, right? Okay, and that's why this is kind of a useful test. So let's see what we get here. This would be 2 to the 4th upstairs. So we have 2 to the 4th, because 2 to the 7th over 2 to the 3rd, you get that cancellation. Now the 3 cubes conveniently cancel, and so you have 2 to the 4th over 5 squared. So it's fairly close in a manner of speaking, but this is less than 1. And this implies that our smallest n, I won't say it, I'll just say it. Smallest n is this guy right here, 2 to the 7th. And I still have kind of a hollow feeling about this because you're never sure if you get everything enumerated, really. There's always, it seemed like I've done this, I did this on paper quite a bit, in a video actually once, and I just was leaving out a lot of stuff. I was making some assumptions that were erroneous. But anyway, this value is what I got. And again, no promises, but it's better than what I did last time. And I think it's probably the smallest n, but I'm not, because I need a formal way. There's a combinatorics way to get all this taken care of. I feel like I got it all. There's 1, 2, 3, 4, 5 so-called factorizations of 64 that appeared to be relevant, you know. 1 times 64 would correspond to this right here. But anyway, this is what I got for the smallest n. And it's very trivial to take the number of divisors and see that it's compose it and then you get 64. That's very simple. So I'll leave that to you if you have any doubts. But anyway, let me know if you know of another one that's smaller. I think this one's it, whatever it is. I'll just leave it in this form. I don't want to multiply it out. I can't. I'm not going to mess with that. But it's, at least from the comparison of these 5 candidates I listed, this is the smallest one. Okay.